Good morning, children. All the centers, good morning. How are you? Yes, Shillong, Itanagar, Tamilong, Senapati, Chuachandpur. How are you people? Yes. Okay. Yes, Shillong. Only one section is there today also. Good morning. Only one section is there. All of you are sitting in the same section, Shillong. All of you are sitting in the same section. Okay, fine. Okay, I guess there are very less number of children today. Okay. So, as per today's schedule, we are going to take only 1.5 hours of class today. Isn't it? You must be aware about it. We are going to take only classes up to 12:30. We'll resume your class at 1:15. The second class obviously at 1:15. So I will be taking class up to 12:30 only, so don't expect a break from my side today. Okay, so we'll be starting a new chapter. But before that, let me know if you have any problem from the last chapters that we have done. Yes. Do we have any problems? Yes, no, anything? Last chapter was easy one. I guess you must have solved some questions from your MCQ books. And obviously you must have gone through your NCERT textbook as well. So do we have any doubts from the last chapters? Like any of the chapters from 11th standard, from 12th standard, any of the chapters? Do we have doubts? Quickly let me know, I will be proceeding. Yes. No? No doubts? Okay, very good. Okay, so I'm proceeding with the next chapter, that is thing. So, as per our discussion in the last class, what we discussed in the last class, all those chapters and everything, what we thought of is that human reproduction, the reproduction whole phenomenon was explained by me that it's the most essential species, isn't it? So now we will be directly coming to the sexual type of reproduction, that is obviously human reproduction. So we all know humans are what? Humans are unisexual. Isn't it? So humans are unisexual, and what do we have? We have certain sex organs. They are called as primary sex organ and secondary sex organs. So what are the primary sex organs? They are the organs which are essential for gamete formation. Isn't it? So under primary sex organs we have two of them, that is the testes in the males and ovaries in the females. Okay, so testes, they produce the male gamete called as spermatozoon, and ovaries, they make their female gamete called as ovum. Isn't it? It's the basic idea what we have about the sex organs. Just mark it. Everybody? So if it is essential for gamete formation, it would be called as what? It would be called as the primary sex organs. Clear? All of you? Clear with the idea? Yes. Any doubts? No doubt. Okay. Let's come to the next type of sex organs, that are secondary sex organs. So if primary was to formation of gametes, the secondary sex organs are for what? They are for formation of passage. As well as union of male and female gametes. So they make sure that there is a passage provided for gamete transfer as well as the union of both of the gametes. So they are said to be what? They are said to be the secondary sex organs. Okay. So obviously secondary sex organs, they will vary in a male and a female. Let's see the male secondary sex organs. The first is epididymis. Next what we have is vas deferens. Seminal vesicles. Obviously these are accessory glands, we know this thing. Prostrate. Bulbourethral glands. And penis. So these all are what? These all are the male secondary sex organs, or also called as accessory sex organs. Now in case of females, let's see the list. They are fallopian tube. Then we have is uterus. It's also called as womb. Vagina. Bartholin gland. Okay. So these are the particular accessory sex organs or secondary sex organs present in both the sexes. Bartholin glands are the particular glands which are present in females which help in lubrication of the female genital tract. Okay. It's present all around the external genitalia and it helps in lubrication process. They secrete certain secretions. Just let me know when you're done with copying. Did you copy, everybody? Yes. Okay, very good. So we'll start up with the male reproductive system. Since we know that humans are unisexual, we'll start up with male reproductive system, the first topic formally in this chapter. So the male reproductive system is basically consisting of what? It consists of one pair of testes. Isn't it? There's one pair of testes which are said to be the primary reproductive organ. Just now we had done this thing. What are they? They are the primary reproductive organ. Okay, nevertheless, the size is not asked, but yes, you can just have an idea that it is round about 4 to 5 centimeter in length and 2 to 3 centimeter in breadth. Just an idea kind of thing. Need not learn these data. Okay, so these data, they are not actually important. So both the reproductive organs, the testes as well as ovaries, they start to develop in the embryo itself. When the fetus is in her womb, mother's womb, there itself only both the reproductive organs, they start to develop. But yes, the development of testes is somewhat different in a way that it starts to descend in the scrotum by the end of the 5th month or 4th month sometimes. So testes, they are actually forming in fetus. I will refer 4 month, and descends into a pigmented pouch like structure by the end of 4th month. And what is this pigmented pouch like structure called? It's called as scrotum. Okay, why is it descending down? Yes, anybody? Shillong, Tamilong, Itanagar? Why does testes descend down? Any specific reason or as such? Yes. How much lower temperature? Very good, Shillong. How much lower temperature? Nice one. Very good, keep it up. Yes. yes, very good. But how lower temperature? How much lower temperature? So this scrotum is basically responsible for providing a temperature of, let's see, provides a temperature of 2 to 2.5 degrees Celsius lower than the body temperature. So whatever the body temperature might be, it is actually 37 degrees Celsius or 98.4 degree Fahrenheit. So it's in degrees Celsius. So it will be giving a lower temperature of 2 to 2.5 degrees Celsius. Why? Exactly, which is required for the process of spermatogenesis. Okay, so the whole process of spermatogenesis is only going to take place if there is a temperature of 2 to 2.5 degrees Celsius lower than the body temperature. Clear? Everybody? Are we clear? So let's see how the structure of the scrotum. I will take you a little bit ahead of what NCERT is supposedly teaching us. So let's see the structure of the scrotum. So scrotum is lined by two different kinds of muscles. Internally, from the internal side. The muscles are, number one, Darto's muscle, and number two is spermatic fascia. So what is Darto's muscle supposedly doing? This helps in regulation of temperature. During cold seasons. By contracting. And what is spermatic fascia doing? This is basically and we have additional structures, or we could say fibers, not exactly structures, and these fibers are called as gubernaculum. Okay? Everybody clear with the idea? Everything is clear? Let's see. So there are two kinds of muscles present in scrotum. They are the spermatic fascia and the Darto's muscle. Darto's muscle, they help in regulation of the temperature during cold and warm seasons, basically by contracting mechanism. And this is what is basically the spermatic fiber fascia. They attach it to the wall of the attach the testes to the wall of the scrotum by additional fiber-like structures called as gubernaculum. So I guess this must be clear up to this. So we had an idea that there was this particular thing, this descent of the testes in the scrotum at the end of the 4th month, isn't it? So this descent is basically because of a canal. Called as what? Inguinal canal. So this inguinal canal is a passage from which the testes, they descend from the abdomen into the scrotum during the fetal life of a male fetus. Okay? Are we clear up to this? Can we move ahead with the structure of the testes? Yes. Shillong, Tamilong, Itanagar, very good. Have we done this? Do you have any doubts up to this? Do we have any doubts? Sure. Okay, fine. So we'll move to the structure of the testes. Okay. Now everybody, this is a typical structure of testes, how the testes looks like across the TS section. This is nothing but this is the TS of the testes. Why is that not? Okay, just a minute. So this is a typical structure of testes. So first and foremost, we will like to see that the particular structure of testes, yes, the particular structure of testes is covered by 3 layers. First, let's write something about it. So the whole structure of testes is covered by 3 layers. This is not given in your book, but yes, if it is required for additional, sometimes additional knowledge. So the outermost layer, the middle layer, and the inner layer. The outermost layer of the testes is called as tunica vaginalis. Tunica in bio means covering. Okay. The middle layer is called as tunica albuginea, and the innermost is called as tunica vasculosa. So we have three layers basically in the structure of testes. Okay, the typical three structures, three layers, which covers the testes. So tunica vasculosa, it covers the testicular lobules. Just show you the diagram. Covers the testicular lobules. Just covering the testicular lobules. And the testicular lobules, they are how many in number? They are somewhat 200 to 250 in number. Okay. Now let's see the diagram. Copy it with this. Now with this, Shillong, copied this. Tamilnong, Itanagar. Clear? Yes. Clear, children? The layers. Yes. Let's see the diagram. Okay. So this must be the outermost layer, what we were talking about. That was what? Is it visible, everybody? Can you see the writing, or shall I? The outermost layer, tunica vaginalis. This happens to be the innermost, middlemost, tunica albuginea, and this is tunica vasculosa. So you have three layers. The outer one, number one, is tunica vaginalis. The second is tunica albuginea, and the third is tunica vasculosa. So you have three layers covering the whole structure, the layered portions of the testes. Okay. So there are many, There are many testicular lobules. How many? There are 200 to 250 testicular lobules. This is structure. There are 200 to 250 testicular lobules. So you can see the testicular lobules. You can see over here. I'm just drawing one of them. There are 250 testicular lobules. Different structures, different compartment-like structures present all over the testes. So 200, 250. Now each testicular lobule contains what? Each testicular lobule contains one, two, three seminiferous tubules. These are seminiferous tubules. This coiled structure. I will again mark in one of them. So it can be either 1 or it can be 3, 2 or 3. So each testicular lobule contains what? Each testicular lobule contains a coiled structure called as seminiferous tubule present in 1 to 3 in number. So it can be 1, it can be 2, it can be 3. Next, we'll move ahead. Now these testicular lobules, they have an opening for the seminiferous tubule to go outside and form a network-like structure. This is a network-like structure formed by the seminiferous tubules when they happen to come out. And what is the network-like structure called? It is called as rete testis. So what is rete testis? It is the network formed by seminiferous tubules. So when the seminiferous tubules, I will be sending this pic to group, don't worry. So just let me write first everything. So these seminiferous tubules are what? These seminiferous tubules are the network-like structures which are formed, the rete testis is a network-like structure formed by the connection of the seminiferous tubule. Now, the connection, they start to open into a different structure. Just I will change the color of the pointer. Okay. So this blue thing. So rete testis starts to come out and they start to form a connection, and this connection is called as vasa efferentia. So what is vasa efferentia? Vasa efferentia is a connection of rete testis with epididymis. And this particular structure is called as epididymis, this coiled structure. This structure is called as epididymis. Okay. Not the outer covering, but yes. This is called as epididymis. So the function of epididymis is to store the sperms. And finally, the sperms are released into vasa differentia or vas deferens. So what happens is vas deferens runs into the abdomen. Okay, just let me take a picture. I'll be sending you this to your group. Yes, what is the matter? Why are you so much indulged in talking? Everybody. Yes. Can you see it? I have sent this picture in the group. Did you get it, everybody? And you can take a screenshot of your picture of your screen as well. The display screen on which you are getting an image, that must be more clearer. Okay? So can you refer to it? Can we see the sections, different sections? You don't want to draw? That was the issue? Was it? Shillong? You don't want to draw, isn't it? Got your point. Since ma'am is not drawing, why should we draw? Okay, no issues. But yes, you should be able to know the differences very well. Yes. So let's once again see the image. You can see the image on the display screen as well. We'll just talk about it. The first layer, tunica vaginalis. The second layer, tunica albuginea. And the innermost layer, tunica vasculosa. And inside the tunica vasculosa, we have many different testicular lobules, round about 200 to 250 in number. And each testicular lobule contains 1 to 3 seminiferous tubules. Isn't it? Now these seminiferous tubules, I've just marked them with red ink. They come out and they form a network-like structure called as rete testis. This rete testis further goes and joins the epididymis through a connection, I've marked that in blue, called as vas efferentia. Epididymis is a particular section which is known to store the sperm. So the storage of sperm is in the particular section called epididymis. Then it moves out and travels down to vas deferens. And vas deferens is what? Is a particular structure that runs into the abdomen section. Clear? Are we done up to this? Everybody? Are we clear? Shillong, Tamilnong, Chuachampur, Itanagar. Okay, what takes time? Drawing image? Shillong? Diagram drawing takes time. Okay. But make sure this image what you have like on your phone does not goes anywhere else. Okay. It's not deleted it in some accident. Okay, fine. So is it clear? The structure, the TS structure of testes is clear to all? Can I move ahead? Yes. Kevin Long? Are you people clear? Let me know if there is any doubt or you wish me to draw this image. No? Do I need to draw this image? Okay, nice. Okay, fine. Everybody. So I'm moving ahead. This structure is clear. So let's move ahead. So this was somewhat the structure of the testes in the scrotum. And this was the... Now the vas deferens starts to ascend in the abdomen, isn't it? One from this side and the other from the next side as well. So I will be drawing only one of the sides. So this vas deferens, what does it do? It makes a loop around the urinary bladder. So this is the urinary bladder. So this will be making a loop around the urinary bladder. But yes, it does have a common exit point. And we have a gland over here. Not exactly in this shape. So this is what is the structure that we are taking from the last diagram. The vas deferens. Vas deferens makes a loop around the urinary bladder. And the part at which there is a particular opening of the, just I have drawn one seminal vesicles, but these are paired structures, they are 2 in number. And this particular structure where the opening of the seminal vesicle or together the ejaculatory duct, then what we have is the prostrate gland, just mark vesicles. Prostrate gland is a one gland, single gland. So many times MCQs like this also you will be seeing that which of these are unpaired. So you have to make sure you are making the correct option that bulbourethral and seminal vesicles are paired, and the prostrate gland is unpaired gland. So this goes inside a typical structure called as, I'll draw the next side, on the next side. There's a structure is called as penile urethra, and from that what we have is the, the foreskin. A typical structure of the male reproductive system. Okay, this time we have to draw since I have drawn. Okay. So any idea for how long the epididymis can store sperms? Yes, any idea for how long the epididymis can store the sperms? No idea. Just write one line about ejaculatory duct. So you get a question, how is ejaculated duct formed? The answer would be vas deferens plus seminal vesicle. They form a structure called as ejaculatory duct. Are we clear? Everybody, Shillong, Itanagar, Tamilnong. Yes, children. Tamilnong, are we connected? It has been long since you have replied. Yes. Quickly copy this down. So for how long the epididymis can store sperm? It can store these sperms for as long as 1 month. Okay. Done? Clear? Shillong? Understood? Everybody? All of you? Yes, thumbs up. Okay, fine, very good. We'll be doing some MCQs after this. Yes. Nice. Okay. I'm proceeding ahead with the accessory reproductive glands. Now, we did the secondary reproductive structures, but we additionally have some accessory reproductive glands. Obviously, we'll talk about male reproductive system only. And the first reproductive gland to be having a side role, accessory role, happens to be the seminal vesicle. So we did this thing that they are what? They are paired structures. They open into what thing? Vas deferens and form ejaculatory duct. Yes, we did this thing. Then is known to secrete seminal fluid or seminal plasma. The composition of the plasma is having a pH of slightly alkaline, 7.3. They're supposedly rich in fructose. Any reason why fructose rich? Why fructose rich? And apart from fructose, what they do have is they have prostaglandins. They have certain components of fibrinogen. They have citrate and many proteins. What is the role of prostaglandin? This helps in the contraction of the female reproductive system. So this is helping in the contraction of So these are the particular composition of the seminal plasma. Let's see once again what are they. First is prostaglandin. Second is fructose. Yes, why fructose rich? Did not answer me. Shillong, Itanagar, Tamilnong. Why is fructose rich? Quickly. Quickly answer me. Why is fructose rich? Without googling. Don't Google the answer. Yes. Quickly. Let's see which center is going to answer first. Think about it. It's very easy. It's very easy. I guess you must be aware, but you are not striking the point now. All of us know this thing, but it must not be striking. Yeah, Itanagar, Shillong, Tamilnong. So out of the male and female gamete, which is the gamete which is motile? Out of the male and female gamete, which gamete is motile? Yes. Quick. Which gamete is motile out of the male and female gamete? Come on, easy one. Answer. Quick. Yes. What is taking so long? Yes, obviously. So what is required for the motility? Do you need a fuel? Do you need a source of energy? Is it? Tell me, do you? Yes, come on. Yes. And what is fructose? Obviously, we know fructose is an energy-rich molecule. So, obviously, this fructose is required for what purpose? If a question like this comes to you, you have to answer that this is required for, I'm just writing it over here, required for motility of sperms. This is very much required for maintaining the motion of the sperms, maintaining the motility in the sperms. Clear? Is it? So this was the first gland, accessory gland, obviously, the seminal vesicles. The primary sex organs remains to be testes. These are all accessory. That is having side role, not producing gametes, but yes, they are providing sources and different kinds of nourishment to the gametes. Next, we are having the next accessory gland that happens to be the prostate gland. So how many in number are prostate gland? The number of prostate gland? There are how many in number? They are single in number. This present. Below the urinary bladder. So it secretes a slightly alkaline prostatic fluid, and this prostatic fluid is rich in, let's draw substances, let's see what are they rich in. Number one, let's start up. Just milky, thick, sticky or jelly-like in its composition. Okay, let's see the secretions of the prostatic fluid or the composition. So what is composed of? In the secretions of the seminal vesicle as well, there was citrate. Here also we have citrate, but additionally we have calcium, which is very, very important. We'll see this process in the next classes, how calcium is playing an important role. So we have calcium, we have phosphate, we have clotting enzymes. Yes, Clotting factor was present in the previous secretion, and we have clotting enzymes over here, and we have profibrinolysin present. So this is going to activate the fibrinogen. So these are the compositions of the particular factors present in the secretions of the prostrate gland. Okay, explore the role of fibrinolysins. So what happens is actually we are clear it out what is semen, isn't it? We all know this thing. We just passed out from class 12th and we know what is semen. Semen equals to the secretions of seminal vesicles, the secretions of prostate gland, and the secretion of glands, all taken together and along with the sperms. So semen is equal to secretions of the glands, the accessory glands, and the sperms as well. So together we call this particular thing to be semen. Okay, clear? So what happens is, let's see the idea of profibrinolysis. What is this going to do? This particular structure, the particular secretion, the semen, is many a times it is in a coagulated state. Why? To conserve the energy. Okay, just to conserve the energy for some time. But after a little while, this fibrinolysins liquefies semen and makes the sperm motile. So this is a typical process where the semen actually initially conserves energy, and when they are lysed or when they are liquefied by the enzymes, fibrinolysins, they start to move. So this is what is the motility factor we need to have. Sorry. Clear? So did you miss out something? Copying part? Apart from understanding, did you miss out something? Did you copy all the slides? All the centers? Everybody? Itanagar, Tamilnong, Shillong? Did you copy everything? Clear with everything? Shillong? Tamilong, Itanagar. Clear? Fine. Prostate gland. This slide did you copy? Everything? Calcium role is still unexplored. I will be telling you that in the next class when we were dealing with the fertilization event. So I will be keeping the calcium part on hold. So what is semen? The secretions of seminal vesicles, prostate gland, bulbourethral glands, and all the accessory glands when taken in composition together with sperms. So let's talk about the third. I guess we have copied all these things. Let's talk about the third, that is Cowper's gland, or also called as this basically secretes transparent pH of 7.2. Yes. The role of this pH is that this destroys the acidity of the, your urine is slightly acidic. pH of urine, done with excretion, the pH of urine, quickly. Since we know that in male reproductive system there is a common passage for urine as well as semen, so they must be encountering the urethra. Urine is having how much pH? That is why you are having secretions which are slightly alkaline, just to neutralize the acidity of the urethra or acidity of the urine parts that are left in the urethra. So what is the acidity of the urine? Yes. So this helps in the neutralizing the acidity of the urethra as well as in the lubrication of the penis. So it's serving two roles. Yes. Acidity of urine is 6. pH of urine is 6. It is slightly acidic in nature. Okay. Clear? And pH of semen, how much is pH of semen? Taking all the secretions together. The pH of semen, just note it down. Where was semen section? This thing. This pH of semen is 7.3. Just mark it. Semen has a pH of 7.3. Everybody. Now let's see. So this was the role of Cowper's glands or the bulbourethral gland. So what is the normal sperm count? We'll talk about some data. This is present in your NCERT as well. The normal sperm count is 20 to 120 million in a single ml of semen. And there's a condition called as oligospermia, where this reaches below 20 million in a single ml. There is another condition called as azoospermia. There is either absence or negligible number of sperms. Azoospermia. So, a human male releases or ejaculates 200 to 300 million sperms, and out of this, sorry, 60%. So if it's 200, 60% of 200 obviously should have normal shape and size, and the remaining 40% should have so the common ones, that is 60% should have common normal shape, isn't it? And 40% should have vigorous motility. So the common ones, that is the one which is having the normal shape, size and motion, they are going to be said to be the fertile sperm, isn't it? So everything should be perfect, the shape, size as well as motility. So that then only the male is said to be fertile. So there is a difference between sterile and fertility, isn't it? We are often confusing with these two words, sterility and fertility. This is what is fertility. So number of sperms should be 60% should be normal shape and size, and 40% should be having normal or vigorous motility. So the ones which are having all the three factors, they are said to be the fertile sperms. So do we have any doubts up till now? Yes, children, do we have any doubts? No doubts? Sure? Itanagar, Tamilnong. Okay, discuss some questions. Give you 2 or 3 questions. Let's see. Since we are falling short of time today, let's try to give 1 or 2 questions. Let's see. Vast difference arises from, first, answer this. Quickly, Shillong, Tamilnong, Itanagar. Answer this question, please. Easy one, yes. In fact, very easy. Exactly, very good. So it's epididymis. The particular structure is meant to store these sperms, and they directly open into a tube-like structure that goes into the abdomen called as vas deferens. Next question. So I'm talking about one testis. Yes. So how many seminiferous tubules are present in one testis? It's easy. Yes. Quickly answer me this. Shillong, Itanagar, Tamilong. I will give you a hint. You have 250 to 200. Just look at this hint. You have 250 to 200 testicular lobules. Obviously in one testis. Okay. And each has 1 to 3 seminiferous tubules. Now can you tell the answer? If it is 250, it's easy one. If it is 250, exactly. If it is 250, it has to be minimum 250 testicular seminiferous tubules. Why? Because if one is present in each of them, minimum, we have a minimum number of 250. And maximum if each of them is having 3. Each of them is having 3, 250 into 3 is 750. So your answer should be what? Your answer should be 250 to 750. Yes, by the time I was explaining, you got the idea very good. Both of you, Itanagar, Shillong, keep it up. So you got the idea and you made the question. Okay, nice one. Okay, so we'll end up our class over here, wrap up our class. And just please, before that, let me know, before you leave, let me know if you're having doubts from this section. We'll talk about seminiferous tubules in the next class. Apart from that, do we have any doubts? And obviously, female reproductive system will continue tomorrow in tomorrow's class. No doubt? Okay, no study. No doubts? Sure, everybody. Shillong. Clear with everything? Okay. Fine. Just give me a thumbs up if it's clear. Crystal clear, everything. Okay. Nice. Very good. Okay, then please, the same thing I will be repeating again and again. Go back home and read all these notes. And obviously, as always I suggest you, don't forget to read your book NCERT. That is the basic thing. AIMS is also merged in NEET, so you must be aware that we have only one exam. So that would be all based on NCERT. So be very, very sure you are covering each and everything, each and every line, golden line from your NCERT book. That's my advice to everybody. Okay, fine. So see you in the next class. Till then, thank you so much. Bye-bye. Take care.